All right, enough theory. Let's actually do something practical. Let's look at our first C program. Now, again, those of you who've done C before, this is boring, feel free to leave. For those of you who've never seen programs before, this is a bunch of things that we don't understand. So we'll take it slow. What this program does is it prints welcome to ESC 101 um, without the quotes. So everything that's in this program requires explanation. And we'll try and understand all of that in this first course, ESE 111 course. So let's go one step at a time and try and understand what this program is and what it does. When I showed you this code, I'm not sure if it was exactly this code, but something related. Some of you, well, almost all of you guessed what printf does, and to varying degrees, some of you had an understanding of these other components and some of you did not. Let's quickly look at each of these components one by one, and we'll go into detail with many of them over the course, but just to get you up and running with your first program, we will look at these in brief detail now. So, what is the first line with this funny hashtag doing? Well, what the hashtag is saying is this is a statement that has to be expanded. It's a header. It's a header that has to be expanded to include information that exists in this pre-existing file. So in a computer, all information is stored in files, and files can be stored inside folders for better organization. But the basic unit of organization of information in a computer is a file. And files, most of the times, though not necessarily always, have a name, and then there's a dot after them and an extension. The extension can be a letter like this, H. It can be multiple letters like DLL or EXE. It could even be numbers or a combination of letters and numbers. And this extension is a way of telling your computer what type of file this is and what programs can open it. So when you use a PDF document, it has an extension .pdf, and then your operating system, whether it is Windows or Linux or Mac, it says, which program do you want to use to open this file? And it gives you a list. It gives you a list of all programs that it knows can open that file. And that information is stored within the registry of the operating system. So in this case, we have a .h file. And a .h file has a special meaning for the C compiler. It realizes that these files are stored in a specific location within the installation of your compiler, and it contains pre-existing functions. Functions are small statements that tell the computer to do something specific. And so you have a library of such functions that other people have written already so that you don't have to do it. So you can borrow from those other people's labor and just borrow their code by including this particular header file into your program. And so the notation we use is we have this angle bracket, open, close, and inside the angle bracket with no spaces anywhere, you put in the name of the header file that you are including. Now, we just want to print something. So we just need this particular header file. stdio stands for standard input output. So we use stdio.h. In later classes, you will see that there are other header files that we could potentially use. But for now, we just need to use this. So we are telling the compiler to include stdio.h while compiling this program. That is why we have the hash, and that is why we have the include. The hash is a way of saying this statement has to be expanded. This is essentially what you would call a macro. The macro has to be expanded, and after that, the code has to be sent for compilation. Don't send it immediately, otherwise it will not make any sense. So we'll look at more macros later on in the course, but this is just your first experience with it. All include statements have to be macroed because they have to be expanded. The actual contents of the stdio.h file have to be incorporated into your program before you send it to compile. It's part of the pre-processing step in the compiler's activity. So that's what the first line is, and you get some picture of it. Now, what do we have here? What does int mean, and what does main mean, and why should we write it this way? So we're getting a little bit ahead of ourselves, and I will not tell you in great detail why it has to be int main and not, for example, void main, the way you can do it in C++. But just know for now that every C program's entry point where the execution of the program starts, the part of your code that the machine will try to run first, is the main function. So the program looks for, or the compiler looks for the main function to tell the machine, here is where the execution of the code has to start. It looks for the keyword main. If you don't have a main function in your code, then the compiler does not know where to begin, which part of the code comes first. So when you and I read something on a piece of paper, we have this intuitive sense that if it's up top, then it should be read before what's below. But the compiler is not human. It is alien, and it has no understanding of what is up, down, left, right. So it only relies on the main function to tell it how to execute something. If there is a piece of code that is disconnected logically from the main function, it will not even run. It will not make any difference to the program's operation. So the main function is important. It is the starting point for the execution of your code. And in C, the convention is that it has to return an integer. Now, again, I've made a statement that I haven't yet explained. Return, what does that mean? And the answer to that is going to come in just 2 minutes. So let's quickly skip forward. What is this bracket doing here, and what is its counterpart doing down below, this curly brace here? Basically, you can think about all the contents between curly braces as being a special subset of your code. The program is going to treat everything that is within curly brackets as something special. Now, how it is to be treated as special is going to depend on the precursor to the curly braces. In this case, it's the main function. So all that the program will know is that it's a function. The name of the function is main, and the contents of this function have to be executed. So that's all it will know. And then it will immediately move to the contents. Printf, all of you guess what it does. The thing that you have to keep in mind is that when it says printf welcome to ESE 101, it will not actually print these double quotes. The double quotes are simply to say everything that is within the double quotes has to be printed verbatim. We don't have to think any further about what has to happen. So the printf statement can do other things also, which we will see in the next class. But the simplest thing it can do is anything you put within double quotes, it can print. That's its job. And so printf does this. And then why do we have this semicolon here? The semicolon is a way of telling the compiler this is one statement. One statement corresponds to one instruction in the assembly language that the compiler is going to translate this program to. And so this one statement, the end of the statement is marked by the semicolon. And similarly, the return 0 statement also has a semicolon marking its return, marking its end. What return does is that it says once this value 0 has been returned to the computer by the program, then the computer knows that the program has stopped working and it has been successful. So again, this is completely alien to our way of thinking, but think about it from the standpoint of the computer. The computer is given a set of instructions to run. It does not know when the program stopped running. And it's not sentient. It does not have eyes, it does not have ears. It just gets instructions, it executes the instructions, but it doesn't know when the instructions have stopped executing. It could take 2 seconds, it could take 2 minutes, it could take 2 days. So the logical way in which the computer realizes that the program has stopped working, and so for example, the computing or memory resources that it dedicated to that program can be freed up and used for something else. It knows this when it gets a return value from the main function. And that return value by convention is 0. When the program executes without any problems, the last line is always return 0. The last statement, the last instruction is always return 0. So if all the other statements executed successfully, then it returns 0. Otherwise, it returns some negative number saying there was a problem with the execution. And we'll talk about that. We'll talk about runtime errors later, but not just yet.